Hello? Okay, let's see if I can do better this time. This is the second example for using PROC GENMOD. We do a ordinal regression model. So here is the data set for the ice cream. It has counts and brands and then taste. Taste range from very good to moderate to bad, very bad. Okay, so the model we're fitting is a cumulative logit model for ordinal data, and the dependent variable is taste. And we're going to demonstrate the use of the estimate statement. So here are the syntax. So you can see there are a couple of things. One is reorder equal to data, and then we're going to use the distribution multinomial and linking equal to cum logit. So that's the command we need to fit the cumulative logit model for ordinal regression. And also we use the aggregate equal to brand. This is the way we need to generate the deviances and other statistics related to the ordinal regression, the Pearson chi-square statistics, the deviance, etc. And type 1 analysis. So basically this is what the model will do, is do a sequential entry for the variables starting from the intercept. In particular, we want to experiment the use of the estimate statement. Okay, so the estimate statement is really, we want to compare the log RR between the brand, that's the categorical variable, and we're going to use compare to the first and the second, contrast the first and the second categories. Okay, and 1, 2, 3, so you get 1 here for the first category and -1 for the third category, and 2 to 3 you get 0 and 1 and -1, and the option exp make us to calculate to exponentiate the contrast to get the odds ratios. Okay, so here we're gonna run it. Okay, and so take a look at the log files. So everything looks fine. So we go to the output file. So here's the output, starting tell you SAS starts to tell you which data set used, the distribution, the cumulative logit, and the dependent variable, and the frequency weight variable. Since we have summarized the data set there. Okay, and the number of observation read, number of observation used 1515, but they actually represent 1045 observations. And for the brand, we have 3 levels, and they have ice cream 1, ice cream 2, and ice cream 3. And the response profile observed value, you have 1, 2, 3, 4, 5, and then the name of the dependent variable is taste. The value is very good, good, moderate, bad, very bad. And here is the total frequency table. And SAS tells you PROC GENMOD is modeling the probabilities of levels of taste having lower ordered values in the response profile table. That's what this option did. Okay, and this is very important for fitting the ordinal regression model because we don't want to mess up with the orders. Okay. Parameter estimation, I tell you the parameters and the variable name and the brand with the different levels. and also give you the criterion for goodness of fit. You got the deviance and scale the deviance. Okay. By itself, it's not very meaningful, but when we have nested models, then we can utilize this type of information. So going down, we have convergence status, algorithm converged. Always good to see information like that. Okay, and now we get into the analysis of maximum likelihood parameter estimates. So get all the betas in this column, and then get the confidence interval limit, and eventually get the p-values. And since we're fitting a cumulative logit model for a dependent variable with 5 categories, so we have 4 intercept. We're fitting 4 logit model here. Okay, so you see intercept 1, 2, 3, 4, and then you have these brand, and then ice cream 1, 2, 3, treating 3 as the reference level, and then you have the p-value to compare the across the categories of brand. And scale is holding up at 1. So here scale parameter was held fixed. And we can look at the likelihood ratio statistic for type 1 analysis. And it's highly significant. So brand is significantly associated with the taste. Okay. And if you want to do kind of the cross-category comparison, like if you compare ice cream 1 to 2, then you get the mean estimate and the confidence intervals, and then you have the contrast, which is I think the exponentiate the alteration. No, alterations here. This is the L matrix times the beta. That's what the estimate statement is estimating. It's a linear combination of the beta parameter vector. So you're contrasting 1 and 2. So this is that estimate. Then you exponentiate it. You get an alpha ratio of 2.8. Okay, and then you get the alpha levels and got the confidence limits. So actually you can adjust for the alpha level as like you can change it to 0.01. So there's some options you can play with. Okay. So in general, this is kind of a piece of sample SAS code for implementing an accumulative logit model for ordinal data. Okay. So a couple of things. The reorder data is really tells the SAS to use a natural order in the data set without changing it. So we need to really have this because we're fitting an ordinal regression. The dependent variable is a taste. In SAS, the default order is a so-called ASCII order. Okay, so if you don't know what an ASCII order is, here's a website talking about different orders in the in SAS. So you have this EBC DIC order, you have ASCII order. So basically, the ASCII order is something like this. Okay. So this is important, and the aggregate statement is to specify the subpopulations on which the Pearson chi-square and the deviance are calculated, and this option applies only to multinomial distribution or binomial distribution with binary single trial syntax response. It is ignored if specified for other cases. So this is specifically for multinomial or binomial distributions. Okay, and here's the source for this information. So you should do more reading in this website. The type 1 versus type 3, these are just different model building processes. The type 1 is a sequential analysis performed This consists of sequentially fitting models beginning with the null, the intercept term only model, and continuing up to the model specifying the model statement. Okay. And the likelihood ratio statistic being between each successive pair of models is computed and displayed in the table. Okay. And also type 1 analysis not available for the GEE model, since there's no associated likelihood. Okay. And the contrast and estimate statement is very important, and there are information available at this website, so we're gonna spend a little bit time. So here, like the contrast statement. So basically, it's used to provide a means of obtaining a test of specified hypothesis concerning the model parameters. So basically, you're testing these hypotheses, and the matrix L consists of zeros and ones. So you can actually testing the contrast of between all the beta parameters. Okay, and estimate is just a kind of special case, or another way to do the contrast. Is very similar, but you also provide a L matrix, and there is the EXP option, so that it will get you the standard errors and confidence limits. So this is really, if we are interested in compare and contrast across categories of a multi-category predictor, then this is a tool for us to use. Okay, I think I'll stop here.